So I'm going to use a random number generator to have some of you share what you think or what you learned analog means, or something you learned about reliability of analog, and then the same for digital. So the first lucky winner on my roster is number 18, which is Derek. So what's something you learned, Derek, about analog kind of definition or reliability?
So analog's like reliability isn't the best because the power is constantly going up and down, and so it's just constantly changing.
Okay, so that's actually the continuous idea. So analog signals are kind of like this non-stop. That's actually one of the pros for analog because it's consistent, non-stop, more information than digital that just has fragments of all or nothing. So that piece is actually a pro because there's more information with analog than there is digital. But there's a word that starts with a D that the reading talked about that is a problem with analog that relates to reliability. So I'm going to give him just a minute to kind of look for that. But he did hit something important with analog is it is continuous.
It's distortion and noise.
Okay, so that distortion. So analog is highly affected and easily distorted. Now, just in case somebody doesn't know, what does distorted mean? Can any help us know what, if something gets distorted, what does it mean?
Like blurry or like hard to see.
Okay, so if it's a visual thing that's distorted, it might become blurry or be changed, basically, right?
Yeah.
So if I'm going to distort Sarah's paper, I can crumple it up. Did I just distort her paper?
Yeah.
I changed it. So any type of I'm having a hard time saying this word, distortion is a change. Whether it's crumpling something up, changing the shape a little bit. Sometimes when people are in accidents, their body gets distorted or, you get hurt. There's distortions with that way. So a distortion or being distorted is a change. So if a signal can easily be changed, I want to tie it to the prompt for our test. So if it can be easily distorted, if we're thinking about reliability, would that make it more reliable or less reliable? I want to see everybody's thumbs. Something can be easily distorted. Would it be more reliable or less reliable? Okay, that's definitely less reliable. Okay, now I want to tie it to something else. So if we have an analog signal being sent out and that signal gets distorted, would that be reliability relating to being stored or being transmitted? What do you guys think? So if a signal is getting sent out and it's getting messed up, would that be a transmission thing that's less reliable or a storing thing? Transmission, right? Because if it's being sent out, it's being transmitted. It's not just being held onto. So it's less reliable in transmitting. So this piece that we learned in the reading being easily distorted is something that connects to being less reliable in transmitting information because it can easily get messed up. All right. We were also told, Derek told us that it is continuous. That means it's non-stop. So it is continuous information that's got lots of pieces, ups and downs. So that is a very important piece. I know the reading talked about continuous voltage. I didn't write that on the board because this reading was specific to electronics. So voltage only applies when we're dealing with analog as an electronic. Continuous applies to any form of analog, whether it's an electronic analog signal or not. So that's the piece. It's a continuous signal. All right, so let's take a look at what we can get from our digital, and let's see who's going to help us with that. Number 22, so that's Jack. Jack, what did you learn about digital?
That it's not continuous like analog. It can just be turned off and on.
All right, it is not continuous. And I see some of you writing this down. If this is helpful to write down to help you remember, please do. Since you can use any of this on your test. So it's not continuous, which means it's either on or off. I can write. And if we're kind of looking at a wave that's digital, that's where there's only two values. In this case, there's either, as the reading pointed out for electronics, binary is that code. It's either a 1 or a 0. So it's either an up or a down. Or if it was like lights, the lights are either on or off, not dimmed somewhere in the middle. So there's an all or nothing value that is assigned to digital. And the reading used the word pulses, and that's kind of, again, the idea. If there's pulses of information, there's chunks being sent out, which is that idea of non-continuous. So that is one drawback of digital, is there is only pieces of information that are all or nothing. But does real life have values in the middle? Kind of like lights, can they be dimmed? There's not just an on or off. There can be brightness levels. So analog can account for that. Or loudness, or anything that's got not just an all or nothing. Analog can account for that. So that's definitely a pro for analog. That digital, if it wants to account for that, it's going to have a set of code for brightness. They'll have to have a set of code for all of those different things. So multiple sets of codes, because they're just chunks or pieces of information. But there can't be a value in between. So that's kind of a drawback there. So what did the reading tell us about reliability of digital? What did the reading tell us?
It said that digital signals are easier to transmit and more accurate.
So they are easier to transmit and more accurate. And I want you to just imagine, if I wanted you to recreate both of these waves I drew, which one would be easier for you to remember to recreate more accurately? Which one do you think? The one on the left or the one on the right? So if I already covered this up and I said draw both of them perfectly, which one would you have more confidence in? I want you to point. Which one would be the one here, right? Because it's just, you've got 3 bumps and there's not variations in height. And closeness is another thing that can get changed in there. So if you look at it long enough, you could probably figure it out. But this one, where there's fewer things to try and remember, it's a little bit easier. That's the idea. Even though it might be missing information, it's easier to be accurate because there's just specific pieces. For example, a pattern of 1s and 0s instead of all sorts of variations. So that's why it's easier and there's tendency to be more accurate, because there's less to keep track of. So what does that have to do with reliability? Would it be more reliable or less reliable because of this? Give me a thumbs up if it's more reliable, thumbs down if less reliable. All right, that would make it more reliable because you can have consistency. And is it more reliable in storing or more reliable in transmitting? There's a word that the reading said that should help us know exactly which one this one is. It's even written on the board.
Transfer.
Transmit. So it's more reliable in transmitting. And what I recommend is we do, as you gain more information, if you write down a fact, when we learn about specific analog or specific digital, try and connect it. Does that tell me anything about the structure of the signals that might be helpful? Does it tell me anything about reliability that might be helpful and what direction it is? And if you're trying to do that evaluation as you're gaining information, it's going to be a lot easier for you to connect it and provide evidence on the test. So the first few times I'm going to kind of walk you through that evaluation, but then you'll want to be able to start doing that on your own to make it easier to connect for the test. All right, so that's the main stuff that we got from our reading. So we're going to watch a video now that'll hopefully help us gain a little bit better of an understanding.